morning, DE students. Today we are going to be moving into 413, which is a continuation of state machines, but today we are going to be looking at a state machine that would involve a toll booth. So there are going to be three different things you're going to be working with this week. There is your activity guide, as usual. There is a worksheet as well, where you're going to complete some analysis of the state graph and the transition table. And then you're also going to be in Multisim Live to create the simulation of the toll booth circuit. So let's get started. Okay, everyone, so starting with your activity guide, the first thing that we are going to look at is, of course, the big concept. Now, you've seen a few examples of state machines and you've learned how they worked. So now it's time for you to kind of go rogue and create your own. I will be giving you a template in Multisim to guide you towards creating the toll booth, but you will be in Multisim Live to create the circuit simulation, and you'll be submitting a worksheet. So our toll booth circuit has four different inputs. We have an open switch push button labeled OS, a closed switch push button labeled CS, an open limit switch OL, and a closed limit switch CL. Each of these have a different activation and output a different logic, and that's all listed on this slide. The toll booth also has four outputs. We have motor open, motor closed, gate open, and gate close, which are just abbreviated with MO, MC, GO, and GC. The gate open and gate close not only have a logic output, but they are tied to an LED. So be careful when you're wiring your outputs to make sure that you include that. Now, looking at your toll booth design, I have provided you with a state graph and a state transition table as a starting point. You are then going to design the state machine that will control the opening and closing of the toll booth. And you need to make sure that your design clearly shows how you implement input combinational logic. So what happens next based upon the state of the buttons and the inputs. Your memory, so how you use flip-flops to create the number of states needed and to trigger the state transition. And then your output combinational logic, so which motor output, open or closed, and what LED comes on at the end of your state. So here are the state graph and state transition table. These are also in the worksheet, so you don't have to keep the slide open. They are embedded in there. Again, these are starting points, so you need to use these to create your design. So you're going to start by doing the state graph analysis, which is in the worksheet. So the worksheet will be posted in Classroom. It will look like this. You already have it leaves the inputs and the outputs at the top. Again, here are the state graph and transition table I talked about. And then on the third page is where you're actually going to complete your work. So here you have your state graph analysis. So what I'm asking you to do is when you see the state and QA and QB are at a certain logic, what is happening to the gate? So I want you to kind of use the state graph to map out what happens during these circumstances. So after you've analyzed the state graph, you're then going to do something similar with the transition table. So looking at the worksheet, you need to go through this worksheet and work through to fill in the blanks of the transition table analysis using the transition table. So you're interpreting the logic of the circuit into this table here. And then you have your design equations, which is your third item. So you need to complete your design equations after they're simplified. I want to see your simplification. Now, if you need to handwrite the simplification and insert the image, totally fine. If you're more comfortable typing out, also fine. Just make sure that you're very clear with how your annotations are being input. So if you're using any kind of symbols to represent certain words or letters that are just labeled differently, please let me know. So like Q naught, please let me know how you're identifying that. So that way you can identify your input and output for your combinational logic. That's what I need from the submission on the worksheet. After you've done the worksheet portions, you're going to go to Multisim Live to create your simulation. This template right here is linked inside of Classroom. In order to get to it, you're going to hit open circuit. If you're logged in, you won't get this message. If you are, you're going to hit open anyway. You can log in that way because you need to actually save a version of this for yourself. So this is the template. Do not save over this template. This is from Project Lead the Way. If you save over this template, we're going to have big problems. So you need to go to, I'm going to hit login to save. So if you've not signed in, it's going to ask you to sign in. And then once you are signed in, you'll be able to save this. I'm going to ask that you save this with your last name in the title. I'm going to hit refresh on that so it recognizes that I have signed in. A little sluggish on my internet today. Okay, so I'm going to go to save as, and you need to add your last name. So I'm going to put Blanford, and I want you to remove the word template from the end. And then we're going to hit OK, and it's going to save that as a copy for you. So now you can see my name has changed, so I can now edit this without worrying about damaging the original template. So please make sure before you do anything to the circuit that you save it as a different file name under your account, so that way it does not mess with that original template. I don't want to have to explain to a master teacher from Project Lead the Way why their template got messed up by one of my students. So after you have, so what you'll see in here is I have given you your, or Project Lead the Way has given you your inputs. We have some flip-flops, and then you have your outputs. Everything in between, you have to figure out how to put together. So take your time. Obviously, if you have questions, reach out. When you are finished with this, you are going to upload this circuit to Google Classroom, and then you are done for the week. So if you have any other questions, just send me an email and we're good to go. Have fun, guys.